Hi class. Today we're doing properties of logs. So we're not graphing today like we did on the last section. We are taking and working with addition, subtraction, multiplication, and division. When do we actually do those things and what do they mean? Now remember, logs are exponents, so they follow the rules of exponents, not what we would normally do. So make sure you have your notes out into properties of logs, and let's go. So we got to remember the product rule, the quotient rule, the power rule. We have to know how to expand and condense. So can I take them apart, put them back together? And there's a cool little thing called a change of base property. Very helpful in the ACT, actually. All right, remember, when you multiply like bases, you are adding exponents. So if I gave you x squared times x cubed, you are adding, the 2 and the 3. So when we are multiplying here, we are adding their exponents. And remember, logs are exponents. When you're dividing, we subtracted, so we are subtracting the logs. And this is a power to a power, which means we are multiplying. It follows the rules of exponents because that's what they are. Now here's an example. I am multiplying. Well, multiplying means I am adding the exponents. So I got to add this. So I have to distribute the log 5 through. Log 5 of 25. Now it's plus the log 5 of 7 because I add exponents when I multiply. Now we're going to redo 25. 25 is 5 squared. We know that this is an identity and it's 2 plus log 5 of x. Okay, pause and do yours. Yours was a little bit different, not much. You had log base 3 of 5 plus the log base 3 of 4. The only thing you can do here is 4 is actually 2 squared. So this is log base 3 of 5. He does not reduce. Plus log base 3 of 2 squared. We can use a power rule, which makes this 2 go in front. So it's a log base 3 of 5 plus 2 times log base 3 of 2. And that's simplified or expanded completely. So we used our multiplication and our power rule. Quotient rule. And remember, when we divide exponents, or divide like bases, we subtract exponents. So we actually have to subtract this. So this is the natural log of e to the 5th minus the natural log of 11. Now remember, natural log means base e, so this actually cancels. This is 5 minus the natural log of 11. Okay, pause and try yours. You should have log base 7 of x minus log base 7 of 13. You can do nothing with x and 13, so that one is completely expanded. Power rule, we just talked about it a little bit. It means a power to a power you multiply. So the 3 to the 9th, the 9 comes in front, and that really means 9 log base 6 of 3. Try yours. Before you do this one here, you have to get the power to a fractional form. Then the 1/3 comes in front, the natural log of x. This time the 2 comes in front. X plus 4 is 1 unit. We cannot distribute through an addition sign because remember, they're actually working with exponents, right? So this just means 2 log of x plus 4. And that is finished. You cannot do anything else. So doing this actually means multiplication. So if I was going to put that back together, that would be log of 4x, and that is not the same of x plus 4. So these two are not identical. Okay, pause and try yours. You should have brought the 4 down in front. Log base 9 of 6. You should have changed the 5 to a 1/2 power and carried it in front, 1/2 log of 5. And now the 4 goes in front. Natural log of x minus 3. Well done. Okay, next, a little bit longer is all. Now we're going to put all of this together. So we have to read from left to right and what's going on. Well, this is x to the 4th times the cube root of y. So we're going to write this out first as addition. So we have log base b of x to the 4th plus log base b, and we're going to change this here to its fractional exponent because that's what we need it to be in. Now the exponents can go in front. Remember our power rule? Log base b of x plus 1/3 log base b of y, and that is as expanded as it can get. All right, now let's look at the next one. This time we're dividing, which means we need to subtract. So it's log base 5. Now remember the square root means 1/2. So x to the 1/2 power minus, now be careful here, log of 25y cubed. All right, this one, the 1/2 goes in front. So a 1/2 log base 5 of x, but this is multiplication, which means I have not expanded this term completely. So minus, and we're going to put a bracket here so we don't get messed up. This is log, and I forgot my base 5 here, base 5 of 25 plus log base 5 of y cubed. All right, we know 25 is 5 squared. So now we have 1/2 log base 5 of x minus, so this one's going to reduce to 2 plus, and then the 3 can go in front, 3 log base 5 of y. Now we have to distribute that negative through. So this really means 1/2 log base 5 of x minus 2 minus 3 log base 5 of y. There's a lot to do there. So when you're doing those type of things in your homework, make sure you're being careful and you fully expanded it, okay? It's not bad, but you have to do it step by step. Okay, try yours. So you should have said, hey, that is log base 2 of 4x minus log base 2 of 3. Well, this can be expanded yet because it is multiplication. So now we have log base 2 of 4 plus log base 2 of x minus log base 2 of 3. Well, 4 is 2 squared, so this cancels to 2, plus, and I can't do anything with this guy, log base 2 of x. Here the parentheses are actually doing nothing because there's nothing in front to distribute, so we can leave them out. Minus log base 2 of 3. And you're done. Okay, this is just the opposite. It's just reminding you, opposite of expanding is actually putting back together. All right, so we're going to condense these. So when addition means I multiply m and n. Subtraction means I divide m and n. A power, something times a log, means this is a power to a power, and it goes up. Okay, let's try a couple of these. So when you're going through here, log of 25 plus log of 4. We're going to take plus means multiplication, so that means 25 times 4. Well, that's log of 100. Well, I know a log with nothing under it means log base 10. So this really means log base 10 of 100. Well, 100 is 10 squared. Since that's technically a base 10, that's going to cancel, and my answer is 2. Okay, let's try this one. This one here's tricky. People usually like to mess this up. Remember, this is one thing and cannot be separated, and subtraction means division. So now it's log of x plus 6 divided by x. Your goal is to get to one log in the equation or one natural log in the equation when you are condensing. So this one here is a little more complicated. So first thing, we have things in front of our natural log, so we need to bring those up because that's our power rule. So that's x squared, and this is x plus 5 to the 1/3 power. Now we look here, and the plus means multiplication. So it's natural log of x squared times x plus 5 to the 1/3 power. And that's done. We can rewrite it in cube root if you want, but this is just fine. Okay, next, try yours. Okay, addition, you should have said, hey, that is multiplication. So that's log base 3 of 6 times 2. We'll write it out, which means log base 3 of 12. This one here means subtraction is division. So it's a natural log of the first one, 4x minus 1, all over the second term, which is 3. Here we have things in front, so we must bring those up first because that's our power rule. So we have log of x to the 4th minus log of 5 squared. Then we know subtraction means division, and we still have 2 logs, so we know we are not done, of x to the 4th divided by 5 squared, or log of x to the 4th over 25. I hope you did a great job. All right, change a base formula. All right, I always use base 10 because it's the easiest one on my calculator. I don't have to do anything to get to it. But what this is saying, if you have the same base, like a log base b of m, and I have both of these numbers, b and m, and I can't calculate on the calculator because I only have base 10, I can say the log of a over m, this one, divided by log of a of b, as long as a's are the same. So if I use log base 10, or just log, it's the log of m divided by the log of b. Here, let's go to numbers. Log of 7 of 8, I'm going to use base 10. So I use log of 8 divided by log of 7. You literally just type that in your calculator and you get 1.069. It doesn't matter which base you use. So if you use the natural log, which is base e of 8 divided by the natural log of 7, you will get the exact same answer. We just use the 10 and the e because those are what all calculators have and are easy to get to. Okay, try yours. You should have said log of 9 divided by log of 2, and you would have gotten 3.17. In your homework, sometimes they say to use the natural log or the log. I actually don't care which one you use as long as you get the answer. All right, good luck, and I hope you do well.